So in this investigation of polynomials, we are going to use the factor theorem. We're going to use the rational zeros theorem, and we're going to find polynomial factors that satisfy a condition, as well as the conjugate zeros theorem. I know this sounds like a lot of theorems, but it's not that bad. To use the factor theorem, that means that if I plug the factor in, so if I have x plus 2, the factor I'm testing is x equals negative 2. If I plug negative 2 into my equation and I get 0, that means it's a factor. I could also do synthetic division with negative 2, and the remainder should be 0, telling me that it's a factor. So let's try this out. So by the factor theorem, if I plug in 5, I should get 0. Or if I do synthetic division, I should get 0 as my remainder. And we do get 0 as our remainder, which means that x minus 5 is a factor of that polynomial. Again, if I have x plus 1, to check if it's a factor, I could plug negative 1 in for x. Or I could go the long way and do synthetic division. And I still would find the same information. It is not a factor. Why would I want to use synthetic division? Because later on, when we actually have to factor these polynomials, doing the synthetic division is easier. But if the question is just asking you, hey, is this number a factor? Definitely just plug in there. So if I tell you that negative 7 is a 0, this is a time when I want to do synthetic division because I have to factor what's left. So when I factor that 7 out, my new polynomial, the degree is decreased by 1 for each term, and the coefficients are going to be the values that are there. Then I'm going to factor 8x squared plus 14x minus 15. And here's the thing, guys, it's a quadratic. If you're not great at factoring, just go ahead and use the quadratic formula. But I could factor a quadratic into that. Please review the factoring handout that went out earlier in the course for how to factor. If I want to use the rational zeros theorem, this gives me a method to find all possible candidates for a 0. All possible. The way I'm going to do that is I'm going to use this ratio of P and Q, where P is a factor of the constant term that has no x in it, and Q is a factor of that leading coefficient. So for this polynomial function, if I wanted to list all possible zeros, I would look at the leading term of 6 as well as the number 6 for my constant term. So P or Q are the factors of 6. So it would be 1 times 6, 2 times 3, 3 times 2, 6 times 1. It could be negative numbers, so negative 1 times negative 6, negative 2 times negative 3. So to list all possible zeros, I'm going to do the ratio of all of those values. So I have the ratio of 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. Then I'm going to have 1 divided by 2, 2 divided by 2, 3 divided by 2, 6 divided by 2. Then I'm going to divide by 3, and then last by 6. And notice there's some repeating values in there that we only listed one time. So if I want to know who is the 0, then you would start the synthetic division process. And you would just start with positive or negative 1 and work your way through till you find them. So this can take a lot of time in synthetic division. This is where I would suggest plugging in 1 to the original equation to find out if you get 0. That will save you a lot of time. Once you find out the remainder is 0, then do the synthetic division. So if I want to know if 2 is also a 0, I'm recopying those new coefficients. 6, negative 1, I'm recopying those. I get 0, so it is. So I know this is going to start factoring out, and I can factor 6x squared plus 11x plus 3 into that. So in addition to 1 and 2 being roots, I know negative 1/3 and negative 3/2 are also roots. So what is synthetic division used for? It's used to find roots. Pause here, go back to the beginning of the problem, and follow me again in this. This is going to be how you're going to solve many of the problems in the lab. if I want to find a polynomial that satisfies specific rules, the number of zeros that a polynomial has is directly related to the zeros of the polynomial. If it's a quadratic, it has 2 answers. If it's a cubic, it has 3 answers. If it's a 4th degree, it has 4 answers. So if I wanted to have the zeros of -2, 1, and 0, that means I'm going to put it into x plus 2, x minus 1, x minus 0. Then I'm going to have to solve for this a value. When I replace x with 2, I find that a is going to be 3/4. So this is probably the easiest problem in the lab. The degree tells me how many times I'm multiplying these factors together. I don't have to actually FOIL them out or anything to find a. I just replace 2 for x, and I set it equal to 6 from that little bit of information. Then I solve for a. So there would be my final equation. I could go ahead and put that whole polynomial together if the directions tell me. Don't FOIL it out if you don't have to. The conjugate theorem looks really complex, but it's really not, okay? What the complex theorem says is if I have positive 2i, you have to also have negative 2i because they come in plus or minus. Also, if I have 1 plus I, then 1 minus I has to also be a root. So they come in pairs. So here, if I know it has a 0 of -2 and 1 of 3 plus 4i, I know that it's a 3rd degree polynomial because 3 minus 4i must also be a factor. So then I can factor this out. Notice I did the opposite, 3 plus 4i, and we didn't have to do anything with that. If it asks me to, then I can begin to expand it out. Only if it asks me to. Don't FOIL that out if you don't have to. And if you're unsure, you can always click Show Me an Example and follow all the steps to the Show Me the Example and see if you actually need a factored statement or a completely expanded statement. So, if I want you to find all zeros and I tell you that 2 plus I is a 0, I also know that 2 minus I is a 0. So I'm going to do the synthetic division for both of those. And then I'm left with x squared minus 3x minus 4 from those values in synthetic division. I know that factors to x plus 1, x minus 4. So now that I had 2 of the roots, I was able to get the last 2 roots myself, which will be a lot of what happens in the lab, is you might be doing synthetic division for a cubic, but you're given one of the roots, and then you're expected to factor it once you get it down to a quadratic.